Good afternoon, everybody. Today we're going to be hearing some thoughts from an AP CSP exam grader, Kiara Shah. My name is John Haydu, and I am part of the Building CS project out of TCNJ. It's funded by the Martinson Family Foundation, and our goals are to increase CS ed opportunities throughout the state of New Jersey, working with legislators and school boards to do that. And for teachers, we've been providing a number of different professional development opportunities and looking into creating a new mentoring program for all the potential CS educators out there. Just so you know, some of our professional development opportunities, which are all free, have been programming with Arduinos, learning about Python, cybersecurity through the realm of Pico CTF, using Mindstorms in the classroom, and tips and tricks for just teaching introductory CS. That's just a small selection of what we've hosted. You can certainly check out our website. You can look at that link, or simply send an email to buildingcsnj@tcnj.edu to find out more details or get on our mailing list. Some things to know about this webinar: if you look under the handouts tab, there are some handouts there. Please make sure, if you want those, to download them before the end of the webinar, because when I end the webinar, everybody's going to be kicked out. You should have control over keeping yourself muted or unmuted, and it's usually just to avoid background noise. It's a good idea to stay muted unless you're asking a question. There's also a chat function. That really works the best if you put questions inside of there. Myself and Kiara will be keeping an eye out to see if any pop up. So we are recording, and this video will be emailed to everybody who attended. It's also going to be posted on our website, so anybody who wants to come back and take a look at it later, it's there for you to see, as well as all of our other videos that we've posted. So, if there's something else you're interested in, feel free to peruse, and maybe you'll find some other information that you find useful. In terms of PD hours, part of our program, and the reason why we can offer all of these things for free, is we need to take some data down, and we will be sending out a feedback survey. If you could please fill that out for us, we'd really appreciate it. And then once we get that information, we'll be sending out PD certificates afterwards, within probably a few days to a week or so. So, that being said, I'm going to let Kiara take over and start talking about all of her thoughts.
Okay. So my name is Kiara Shah. I teach computer science at Ranney School, which is in Monmouth County, New Jersey. And I'm the only computer science teacher at my school. So I was really excited to be selected to attend the reading of the very first Comp Sci Principles exam, because I wanted to just talk with other Comp Sci teachers. I have never done the reading, even though I've taught CSA for about 5 years now. I haven't had the opportunity to do the reading, so this was my first reading ever, and I learned a lot. So hold on, gotta figure out how to get to the next slide. I got it. So it's my first time at a reading. This is a photo of me in Kansas City with good old Samuel Clemens there. And I was there with AP Stats, Biology, English Language, and Composition. So every day at breakfast, lunch, and dinner, I got to sit with all of these other wonderful teachers and talk with them about how their reading's working. It was very long, though, I have to say. We started on a Saturday, or we arrived on a Saturday, started work Sunday morning bright and early, and we didn't leave until the next Sunday. So it was really like 9 days of actual reading. I highly recommend this if you're looking to do a reading. However, I hear that they're looking to have readers read from home. Eventually, they want everybody to read from home, because I'm sure it's cheaper than flying thousands and thousands of teachers all across the country and putting them up in hotels and feeding them. So if you get a chance, definitely grab it while you can before they start making this 100% all at home. So I wanted to start this with some tips and tricks that I picked up while I was at the reading, because I didn't want to leave this till the end, so because maybe we would run out of time if we didn't get to do this. So quickly, I'll go through these tips and trips. Every time I was talking with a teacher at lunch, I would jot things down on my phone and just like say some things. This first one I was really excited about. Someone at the reading announced that he's crowdsourcing writing 300 good quality AP CSP multiple choice questions. The biggest problem that I had last year when I was teaching this class was that there are no practice questions for my students. And the one little book that was released maybe in February I didn't think it was very good. So a bunch of teachers signed up at the reading, and it's going to happen, but I don't know when it's going to be available. So hopefully we'll hear about this at some point, and we'll be able to have some good questions that other teachers can, that we can all use. Someone else mentioned that teachglobalimpact.org is a really good website to go to get resources to teach the big idea number 7, global impact. So he suggested we check out the website, and I went to it, and it has lists of resources and curricula and lesson plans from all 7 different curricula. Some code.org, CS Matters, Mobile CSP. So that's a good resource to go to. Someone else mentioned that the Blown to Bits books has actually new updated chapters, which I didn't know about. I think about 3 different chapters have been updated, and I think there's maybe even a new chapter. So you can find it at this link. If you need some data for students to work with for the data unit, you can go to this website. I'd never heard of it. It looks awesome. You can download a lot of data sets. And this third tip here, if you teach CSA, I highly recommend this interactive Python / textbook thing. It's unbelievable. I've been playing around with it for the last couple days for my CSA class to give them practice problems for the AP exam. Definitely loved this tip that I got. This one is really good. Dan Garcia, who is from the Beauty and Joy of Computing curriculum, you could just watch his videos for free. You can go to YouTube and find all these videos. He teaches CS10 at Berkeley, and you could go and just watch the video on abstraction or algorithms or recursion. So if there's a topic that you don't understand or you want to show your students, or if you have a student who's absent or who's struggling, you can direct them to these videos. So I really liked getting this tip. But this one, I have to say, takes the cake right here. This guy from code.org created this code print program. I'm going to actually show it to you because it's so amazing. What you do is you go to this code print place and you copy and paste your code into, so this is the code print right here. You copy and paste your code into here, and you can, change the font size. So you can see down at the bottom what it's going to look like when it gets printed. It actually looks really pretty, nice, colorful. You can say, I want to put an oval, and you click on the oval right here, and you say, this is where I want to put my oval. You just drag it, and you can put the oval where you want. And then you say, this is where I want to put my rectangle. So you click on rectangle, and you put it right here. So now you've easily put ovals and rectangles on your code. So I saw tons of students who had used this when they submitted their code, and I wish I don't know how I missed this last year, but it's a wonderful resource, so I recommend you have your students use this to submit their code. Made it really easy as a reader to grade the code. So let me go back to the slideshow. So when I first got there, everybody was wondering, are we going to be grading the create task or the explore task? And I really, really wanted to grade the create task. So I was so excited when I got there and I looked at the list. I saw, yay, I'm selected to do the create task, because that's really what I wanted to see. I wanted to see a whole ton of different create tasks. So I ended up grading about 300. This is just an estimate. Maybe I did more, I don't know. And all sorts of different programming platforms and languages. We did Snap, Scratch, Code.org, App Lab, App Inventor, Alice Processing, like this whole list right here. The ones I've circled here are the ones that I actually know and have taught before. I also know Robot C and ModKit. So if someone had submitted a project in Robot C with their robot, that would have been amazing. I would have loved to have watched a video of a robot running around and doing specific tasks. I would have been able to grade it, but I didn't see any of that, unfortunately. I thought that when I applied, because I told them what language that I teach, that they would put me on those tasks, that I would only be seeing code.org projects, or I'd only be seeing App Inventor projects. But it turns out that everybody was there, graded everything. You just click on the next project, and up it pops, and you got to see what it was. And if you weren't familiar with it, you just struggled, or you asked a neighbor, hey, what is this? I've never seen this before. And honestly, the programs are pretty simple. So I never had a trouble like understanding how Alice works or processing. I saw this really interesting one called Lua from Brazil, and we had Java projects, HTML projects, so there was a lot of different programming languages and platforms. So the highest scoring projects that I saw at least 3 super Sudokus. I saw Japanese, I don't even know how to pronounce this, but it's Otome maybe. It's a story-based video game aimed at females. It was gorgeous. Lingo was a really good one. I saw a college recommendation app that had tons and tons of logic, where it says if you want a big city and a small or a small school and urban or rural, and it just had lots of logic. That was great. Someone made a health/calorie counter app that counted steps and tracked food. The app that used the phone's accelerometer. So basically, he had a video of himself running, and he showed you the app on his phone. So it was a weird camera angle, but he showed that as he ran faster, the music started playing, but if he slowed down, the music stopped, and he was able to set goals for himself in the app to keep on a certain pace. I saw a graphing calculator that was written in processing, and this funny one, I loved this one. It was a calculator written in Python, and the student described it as a mathematical innovation for calculating totals. So I thought that was really funny. I wrote that down, and that was in my notes. One of the things that really made me sad was to see some beautifully coded projects. They had obviously taken AP CSA, and just gorgeous programs, but they didn't score well at all because the user didn't answer the questions. Like, some of them even left the questions blank, which it blows my mind, but maybe they ran out of time. I don't know. But you could see that they put all their effort into the code, and they didn't no effort in the questions, and their score was terrible. And that made me feel bad, because I'd love to see beautifully written code and programs. So that made me sad. Oh, the very last one I graded, it happened to be literally the very last one I graded, was spectacular. It was an image generator, so it generated little JPEGs. You picked how many colors you wanted in the JPEG. You picked how many rows and columns, so it was going to make a grid of different colors. And it created every single permutation of those colors with those dimensions. It was spectacular. So that was a very good way to end and that one I literally wrote down the details on that one because it was wonderful. On the other hand, there were a bunch of low-scoring projects. For instance, there was an Alice simulation, or most Alice simulations were absolutely terrible. People who just had a series of commands that says, okay, have this character turn left, turn right, spin in a circle, raise his arm, lower his leg. They just were literally command after command after command with no logic, not even any functions. They were not good. I didn't see a single Alice program, actually, that was good. It didn't mean that they didn't exist, I just didn't see it. There were tons and tons of code.org clicker games. And because I teach the code.org curriculum, I'm very familiar with the lesson and the curriculum, and I know these students just took the game that they did in the lesson and they submitted it as their project, which they're not supposed to do. Some of them literally submitted the exact project that they did in the lesson, and when that happened, we moved it up the ladder and flagged it for plagiarism, but I honestly don't know what happened to them after we sent them up the ladder. Some of them were modified versions of the clicker game by perhaps they added levels. Those didn't score very well either because they were missing what was really important, was having 2 child functions inside of a parent function. So it was hard for these students to get that with the code.org clicker games. And I'm going to talk more about the two child functions inside of a parent function in a minute. So I recommend you tell your students to avoid clicker games unless they really pump them up with lots of, like, you know, power-ups and bonus levels and just a lot of stuff that is beyond what the regular curriculum does. Choose Your Own Adventure apps could go either way. They were either really trivial or they were spectacular. There was nothing in between. The ones that were trivial were the ones that where you click a button and the screen changes. And then you read and you click a different button and you go to a new screen. Because all they're doing is clicking a button and setting a new screen. Those did not score well. Some clicker games were absolutely amazing. I mean, I'm sorry, not clicker games. Some adventure games were good, amazing. And I have to say most of them were just simple text-based games, and they were not in a graphical environment, where the character, you type in a word, you say, I want to buy money, I want to, you know, grab this power up or use this weapon and fight against these monsters. They were amazing. I recommend telling your students to avoid Choose Your Own Adventure games as if the user is simply clicking buttons to go from screen to screen to screen. So let's get on to the create task here. In the create task, they could earn a total of 12 points. So each row in the rubric was 3 points. And you could either get 0 points, 1, 2, or 3. So let's take a look at the first row. So the first row was the video row, where they had to submit a video and they had to have a written description or a narration that summarizes the video. And one of the things is they had to talk about the purpose of the app. And there's a slight difference between the purpose of the app and the function of the app. So the purpose is the intended goal. So this app is intended to help someone manage their calorie intake or manage their exercise. A lot of people forgot to talk about the purpose and they instead just said the function. So this is how my app works. And we decided, or it was decided by the table leaders before we arrived, that points would be awarded even if they only talked about the function and they didn't mention what the purpose was. Most students, the vast majority of students, earned the full 3 points on the video. And I had to give zeros. They either earned 0 or 3. You give 0 if there's no video submitted, like the person just somehow forgot to submit it or there was a technical issue. So most students earned all 3 points. We were also told to give them a benefit of the doubt if we weren't sure if they talked about the purpose or the intended goal. Give them the benefit of the doubt. You can sometimes infer based on the name of the app what the purpose of the app is. So even if they didn't clearly state it, we could infer it. So that's row 1. Most people got those 3 points, which was nice because the next couple of rows came into some trouble. The second row was talking about the development process, and they had to identify 2 steps in the process that were either difficulties or opportunities. They had to talk about how they resolved both steps, and they had to specifically mention that at least one of those steps was completed independently. So people started losing points here because they didn't mention that they did it independently, or they only talked about one opportunity or one difficulty. Another reason that they didn't earn full points is they didn't talk how the opportunities were resolved. So if they said, I brainstormed solutions and solved the problem, that doesn't give specifics. We needed to know what they specifically changed in the program. If they said, I changed the code around, that also is not specifics, and you can't give them points for that. If they said, my teacher helped me during the developmental process, that was not good. If they said that my teacher told me to go to the internet to find the solution, that's okay. So if my teacher helped me, that's bad. If the teacher tells you to go research it, that's okay. The interesting one here in this last bullet point is some of them said things like, my brother helped me, or my sister helped me. And we were to infer that possibly that brother was in the class. So we were told to give them the benefit of the doubt if they said something like, my brother helped me. Obviously, if they said something like their parent helped them, then that, obviously the parent's not in the class, and that would be flagged for plagiarism. But my brother helped me, we were supposed to say, well, maybe he's a twin and he's got a brother in the class. So that was pretty much the development. Oh, I did put up here how many points you earned based on, at 1 point. If you identified one step and it was independent, you earned a point. If you identified 2 steps, maybe you resolved one of them, and one of them was definitely independent, you earned 2 points. And to earn all 3 points, you had to have 2 identified steps, 2 resolved steps, and 1 independent step. Now we get into the really tricky part, which is the algorithm row, followed by an even trickier part, which is the abstraction row. So the algorithm row, I mean, there were so many debates and questions that we had over the course of grading. I have to tell you, the first 2 days that we were there, we didn't even start reading the projects. It was all training and trying to do something called calibrating, where all of us as readers go through a practice set and make sure that our grades match what has been predetermined to be the grade that project should get. We had a lot of trouble calibrating because questions came up. Is this an algorithm? Is this not an algorithm? Is this abstraction? Is this not abstraction? It took us days to resolve these issues. And on the first day we were told one thing, and then after 24 hours of debate and talking about it, they changed their mind and we went with another thing. So this took a while. So here's the thing. An algorithm really has to have, obviously it has to have math or logic because that's what they told us it had to have. But a lot of people just put in an algorithm that had a series of steps. So they would circle, or I can't remember if it's ovals or squares or rectangles right at this point, but they would identify their algorithm, and it would be walk forward, turn left, go right, and it would just be step, 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 step. And that definitely didn't have any math or logic. And here's the interesting thing is we were actually looking for 3 algorithms. They had to identify, this is my parent algorithm. And then they had to identify within that parent algorithm method calls or function calls, whatever you want to call it, to 2 children algorithms. So we're really looking for 3, and I think a lot of people thought that they only wanted 2, like a parent and 1 child. So this was very difficult to earn all 3 points in this step. So a sequence of steps is not an algorithm, they decided, because it doesn't have math, like an Alice simulation or a series of set screen commands where you're just going, change this screen, go to this screen, go to that screen. You have to have an if statement, selection, loop, iteration. Math.random is considered math. As far as the purpose of the algorithm, if the name of their algorithm or their function or procedure is descriptive enough, that's enough to identify the purpose. So if you have a function called generate random number, that right there tells you what the purpose of that function is. The student doesn't need to go into any more detail or description about that. I hope you're probably going to have questions about this, so I'll let you guys ask the questions in a minute. But anyway, the biggest problem with the algorithm is in this, if they did not have math or logic, they earned 0 points. Even if they did a lot of the other things, that's if they talked about the purpose and they described a parent algorithm with 2 child algorithms, and they did everything else, if they literally did not have any math or logic, they got 0 points. And teachers were really upset that it was such an all or nothing thing. So that's primarily why they've changed to a binary rubric for this coming year. So where check, do you have math or logic? 1 point. Have you identified the purpose? Another point. So I think that's going to be a really great improvement for students to earn a little bit more points. Next one is the abstraction one, and this one I have on 2 slides because this was really meaty. We had a lot of arguments and discussions about this. So the thing was, what is abstraction? Well, when we first got there, we were told that if you can envision a piece of code as being encapsulated, like if you could look at the code and say, you know what, that would be a great function, and let's make it, and it's not really a function, but hey, I could see it as a function, and I could see it as a standalone algorithm, that is abstraction. Then, after much debate, told you it was about 2 days of this. They decided that, you know what, it really did have to be encapsulated in its own function. So it had to be a separate function. So if the person circled a few lines of code that were just random lines of code mixed other all lines of code, and they said, this is my abstraction, and it wasn't a literal entire separate function, that did not count as abstraction. So you're probably thinking, oh my God, I know some of my students already lost points because of that. So that was one debate. Another debate was when they talk about managing complexity of their program. A lot of people say, oh, I use this abstraction to reduce the code. And that's all they said, to reduce the code or to simplify my code or to have fewer lines of code. If they didn't talk about the fact that abstraction is useful for code reuse, so I want to reuse this code in multiple places in my program, they did not get the managing complexity point, or that didn't count. So that was another issue. So code reduction doesn't count. Code reuse is what we were looking for. Another big, huge, this was the biggest argument. This really is what caused us to have a 2-day delay before we even started grading, was the fact that buttons, a lot of students said this button is my abstraction. I just click the button and it does what it's supposed to do, and I don't have to worry about what the code is. It's just, this is my abstraction. The problem is, if you read the language, it has to be a student-created abstraction. Honestly, it's not in this rubric right here, which I'm kind of surprised. I'm looking through it right now. But the abstraction has to be student-created. And buttons in like App Inventor or code.org, when you pull out a button, that thing that you're pulling out is part of that program, is part of that programming language. They created the button. You're just adding code to it. So the button in and of itself is not an abstraction because the student didn't develop it themselves. However, if the button calls a function that the user created, that's abstraction. So you can have a button, lots of code inside of it, doesn't count. If you have a button where if button's clicked, call this function or call this method, that counts. So I have more on the next slide. This was an interesting one. This is an example they gave us. So abstraction can be as simple as, hey, look, I use math.random a lot throughout my program. So I decided to create a method called random number. It has one line of code in it, and now I can reuse it over and over and over again. So that random number function is the abstraction, because I can reuse it. Remember, code reuse is the big part here. Another thing that counted was I made a list or an array instead of using lots of different variables. There was another debate. Is a variable an abstraction? Technically, a variable is an abstraction. However, variables are not user-created. Like a variable exists within the programming language. So if a user identifies a variable and says, hey, that's my abstraction right there, variable X, that is not a user-created abstraction. Variables don't count. However, if you say I made a list with, instead of using lots of different variables, that's an abstraction. There is one weird thing that I still am not quite sure I understand, or maybe I do. In Snap and Scratch, to get things to happen, you have to do this broadcast, where you attach code into a broadcast. Even though that's kind of like a button where your user clicks a button and you have code in it, if you've got broadcast, it has code in it. That was considered an abstraction because the user had to create the code in the broadcast. However, the caveat was it had to have more than one line of code. So a broadcast couldn't just call one function. It had to do more than one thing. Another thing that they mentioned to us was that in Snap and Scratch, clones are okay to be considered as an abstraction if they were created inside of a loop instead of making many separate individual sprites. So if the user says, look, I could have created 20 different individual little sprites on 20 different lines of code, but instead I decided to use a loop, which means I'm kind of reusing the code each time I go through the loop. I'm reusing the same code over and over and over again. That's okay. So that's just if you teach Snap or Scratch, maybe that makes you happy. I don't know. So that is basically some of my thoughts and notes on the create task. If anyone has any questions about it, definitely ask me. We'll have time in a few minutes to answer questions. I did get some details on the explore task. Basically, once we did get started on the grading, we got faster and faster every day. Like, I think we kind of surprised them at how fast we became at grading these things. We finished a day early, which was amazing, because I have to tell you, the biology people had to do overtime because their grading did not go as well as ours, and they had to start doing extra hours. So we finished a day early, and because we finished a day early, we were able to cross-train on the other task. So in that last day, I went to, sat for a couple hours, and I learned about the Explore task, and I wrote down some notes. So this is kind of like a info dump or a quick summary of the notes that I took. I still didn't go through the whole grading process of this, and I still have some questions myself on this, but these are my notes. So the biggest thing that I took away from this is that the innovation that the student uses has to have a computer in it. It's a computing innovation. A chip on a card is not a computer. Oh boy, several of my students did chips on cards. Oops, my bad. Now I know why they got 2s. So that was the one thing. So the innovation, like with the chip, the actual innovation is the chip reader, not the chip itself. It's the reader, which has the computer, the processing device in it. So students have to identify the purpose versus the function, which is what does the device do? And I think there was some question as to, well, what's the purpose versus what's the function? So I'm not exactly sure what they all talked about, but basically they decided, purpose is what does the device do? Another thing I know they talked about is what is an effect. So the effect of the computing, it's something that has to happen on the individual or the group that's using that device. Cost is not an effect, and I know some of my students says, oh, this is really expensive, so not everybody can afford this, and that is going to be my effect on society. Well, it turns out cost is not an effect. It just is what it is. Cost, that's what it costs? Okay, that's what it is. Also, the impact has to be on society, economy, or culture. Some other people had impacts on the environment, which I think they're actually thinking of adding as a category, that the computing innovation could have an impact on the environment. But stay tuned for that. So for last year, it had to be society, economy, and culture. Also, another thing that I didn't even really think about until they told me was that a single effect can have both a beneficial or harmful. It can be both beneficial or harmful depending on the group that's impacted in your perspective. So for instance, with this example down here, a self-driving car. The function of a self-driving car is that you can drive without a person. An effect is that there are fewer accidents. An impact of that effect is lower insurance rates. So that's good. It affects society and the economy. But if you go back up to the effect of fewer accidents, a beneficial effect is fewer accidents. But maybe a harmful effect could be mechanics. Because now what are the mechanics going to do? They're not going to have any cars to fix. So you can have the same thing, have a beneficial and a harmful effect. Next slide. Data was another issue that it seems like a lot of students didn't have a handle on what they were asking for in the data question. So data is consuming data. So what does this device consume or produce? Well, consuming means what is the inputs, and producing means what are the outputs. The word information was not enough. So if a student says, oh, this device generates information, it's not enough. I love what they said here. They said, imagine that it has to be something that can be put into a variable. As soon as they said that, I'm like, oh, duh. So it's got to be some sort of integer, a temperature, a Boolean, a true or a false, a sound file, a fingerprint file, video images, and so on. And we need to know, what does the device do with that data? How does it input it, and how does it output it? So, wow. I feel like I was talking really fast there with all of this stuff. But I'm at the end. So now if you have questions, please feel free to ask them, because there's probably something I didn't mention here. And so shoot away. Please ask questions. If you want to just speak it, you can turn on your microphone, I think. Or you can type it into the chat box, and I can answer it. So, any questions? No? Would I do it again? No one asked that, but I'm going to answer it anyway. Yeah, I would definitely do it again. And I really would like to actually do it in person, because I loved collaborating with other teachers. I loved talking to them, getting tips and tricks and ideas from them. And it was great getting away from real life and going to be a comp sci geek for 9 days. I really enjoyed it. No questions? Still? Oh, maybe there's a section here that I'm missing. Oh, nope. No questions.
Well, I can certainly ask one for you.
Oh, good.
Yeah.
Thank you.
So you said in terms of actually becoming a grader that they're planning on changing over to just remote grading.
Yes.
Are they planning on lowering how much they pay as well? You know, how do you know how that's going to work? Or
Ooh, no, I did not. I'm not sure anybody asked that. That's a really good question. The biggest concern that teachers had with the going to like home grading was, if we tell our administrators that, hey, I've been selected as a grader and I could do it at home in my pajamas, that our principals and people are not going to let us get off of school to do this, because we're just going to be sitting at home. It's not, they're not going to consider it as professional development if we're just sitting at home getting paid by another company to do something. So people were like, well, then the only time we're going to be able to grade is in the evenings or on the weekends. So it's going to take a 9-day process and stretch it out over maybe several weeks, where you might come home and spend an hour or two grading a night, and it'll be just a long, drawn-out process. So you might not make as much money, because you might not ultimately put in as many hours. So that was a big concern. Also, the camaraderie effect, and the fact that every time I had a new project in front of me, if I had a question, I just literally turned to the person next to me and I said, what do you think of this? And we could chat about it really quickly. If you're going to an online system where you might have a chat feature in the corner of the box, and they did in the computer system we were using, there was an ability to chat with other users, but it's just not the same thing as having them right next to you.
right.
So someone floated the idea of having like little regional training, so you could get like a 1 or 2 day experience, like on a weekend, say go to Philadelphia or go to Boston or go to Atlanta, closer to home, fewer hotel nights, so it's cheaper for the College Board, get the training, work out all the kinks, and then go home and do the grading from home. That was floated as a solution to, because I have to tell you, I don't think a single teacher was happy about the whole grade at home thing. They really weren't. So it's still, I know they're going to do it like maybe as a pilot next year. They're going to take some of us and say, hey, do you want to grade at home? Maybe to get us to do that, they'll have to pay us more.
Yeah.
I don't know. I don't know how they're going to get people who want to do that, because now it just sounds like an evening job when I'm already working, and I don't know.
Right. It looks like we have one question from Laura, and
Yes.
The chat window doesn't look like it's opening. Laura, would you like to actually ask your question?
Yeah.
You're currently muted, Laura.
Oh wait, maybe I can see it. It's like with this tiny little window. Oh, oh wait. I think if I expand this, I can see some questions. Hold on a second. I have to read it line by line. Can you describe in detail an explore task as well as a create task from start to finish? From start to finish. I'm not sure what that means. I
just unmuted you, Laura, so if you're having problems before, maybe it works now.
Hello? It does say muted. I don't know. I'm not sure. Describe and explore task, like maybe from, is this your first year teaching? Because maybe you haven't gone through the whole process of running students through the entire. Ooh, do we hear someone? Hello? I'm hearing.
Here's somebody now.
Yeah.
All right, Kevin, do you want to share your question?
Oh, here's a question. Okay.
I wasn't really asking a question. I was just saying that it was muted by the organizer.
Oh, it does.
By the person.
Right.
But now you opened it up for everyone to talk.
Laura says yes, but I don't know yet. Yes to what is it? Yes to my question that this your first year teaching and you are like panicking about how to run your students, in through an entire explore or create task. Yep. Yes, you're panicking. Okay. Cool. That was me last year. I really had no idea what to expect. I honestly didn't even read the rubric very carefully because I was like, let me just survive this year and hope that my students earn some sort of okay grade. None of my students got 5s, by the way. I had a lot of 3s and 4s and a couple 2s. So I did a pretty good job. My average was slightly higher than the rest of the country, so I'm happy about that. But I know now I did so many mistakes last year. So Laura's saying, I'm not sure what the final products are supposed to look like. Okay, so for the explore task, the vast majority of people who submitted as explore task submitted almost like a slide, like literally one slide, where they put on a couple of images and a few words of text that's supposed to represent the computing innovation. So that's the first piece, that they have to create their own graphic. I think that's what it was called, about the computing innovation. So if someone were to imagine it as like a poster on the wall, if it was blown up, that you could look at that and you could say, oh, that is self-driving cars. Obviously, that's self-driving cars. And if that graphic could like show how the innovation is inputting data and outputting data, even better, but that doesn't really, it just needs to be kind of like a summary of what the innovation is. Like my son, who was in the class last year, I'll say right flat out, he did prosthetics. So like for amputees, thought-controlled, I think it was called thought-controlled prosthetics. So he had a picture of a bionic arm and a picture of I forget what a couple of pictures are, but it's basically supposed to be like a mini poster. You could do a video, I think, but the vast majority of people did these little images. And then you have to answer 4 questions. So the bulk of the project is really answering 4 questions about the computing innovation, and they have to provide research to back up what they're saying. They have to provide sources. The research has to be from within the last 6 months, I believe, or no, from last May, anytime after last May. So from May 2017 onward, they have to find some articles or things that support what they're saying in their questions. So were the questions in a document? Oh yes, the questions are definitely in a document. Yes, and it's like an infographic, absolutely an infographic. So that's the explore task basically. And the questions are definitely, you can download the questions right now. I mean, I think they didn't change the questions hardly at all from last year. So you can go, just Google 2017 to 18 AP Comp Sci Principles Explore task, and you can find the questions. As far as the create task, the student has to create some sort of program, an app, a program, a game that has a purpose. And honestly, every app that's created has a purpose. Like, if it's a game, the purpose is to entertain, to have some fun, to relax. Some people, it was so funny how some people described it. They would say, this is to allow someone the chance to relax after a long day of homework or work at school. And that was the purpose of my app, is to provide some fun for my friends. So they have to write a program, and then they have to videotape the program running so that we can see that the code is actually working. And the video is very short. It's less than a minute long. And then they also have to submit their code. So that's when I showed you the code print thing from the guy Baker. If I go back here, all the way back, if you go to the code print, this is when they have to submit their code, and they have to put an oval around the part that is the algorithm that they're identifying, and a square around, I think it's the other way around, a rectangle around the algorithm and an oval around the abstraction that they've identified. So that was hard for some students to figure out how to do. So this amazing thing, perfect for code print. And then they have to answer 4 questions as well for the create task. And that was where students just did not put enough effort, or they didn't answer the questions in the right way, and they lost a lot of points by not answering. Oh boy. Anyway, does that answer your questions? I hope it answers your question. There are sample tasks, by the way, online that you can look at, and they can show you this was a high-scoring task, and this is why it's a high-scoring task, and this is a low-scoring task, and this is why. So that might be a good place to go. I showed my students only the high-scoring tasks, and last year one of the high-scoring tasks was a choose-your-own-adventure game. So guess what? 9 out of my 20 students did choose-your-own-adventure games, which is probably why I'm not so pleased with choose-your-own-adventure games, because they were a little boring. So, any other questions? Ooh, hold on. So, I'm reading. Hold on one second. So, for each task, there is an accompanying document answering the questions. Yes. So, for the Explore task, students have 4 questions that they have to answer. And for the Create task, there's 4 questions they have to answer. Do students need to do some kind of data analysis? No, they do not. Do students need to create a computational artifact? No, they actually don't need to. No. For the Explore task, where they research a computing innovation, if they find like maybe a histogram or a bar chart or something, they could put that into their computational artifact or their little slide or their infographic. But they don't have to collect data themselves, and they don't have to generate that bar chart or whatever, or pie chart or whatever. They don't have to do any of that themselves. They can just say, look, I found this at this website, so they have to cite their sources. So they don't have to create it. Thank you. Thank you. You're welcome. Any other questions about that? If I could go back in time to myself 12 months ago, my students would have all gotten 5. So wouldn't that be awesome? Any other questions? No?
So it looks like Laura had one more. Can you give a good definition of
a good definition of a computational artifact? Ooh. Can I give a good definition? That's a good question. That's something I would ask my students and let them go find the answer for. I think it's an artifact that shows the computing innovation that shows the purpose of the computing innovation, because that's the biggest thing with the computing innovation is you need to be able to identify the purpose and the impact of it. So if you can create a video or a poster or an image that shows, definitely has to show the purpose. Does it have to show how it's affecting things? Not necessarily, because you do that in your writing. In your written responses, you talk about the beneficial effects to society, economy, or culture. So if I had to define it, I would say it's computer-generated graphic, shows the purpose of a computing innovation. That sounds good to me.
Okay, so I guess that looks like we have answered all the questions. Thank you very much, Yara, for doing this presentation. I'm sure all of us who are here and the people who are going to pop in and watch this afterwards appreciate your time and effort.
Great, thank you.
So if everybody could remember, fill out that survey, and then we'll be passing on the PD cert as soon as we get that data. Thank you again.